Okay, let's get started now. We're recording. So, the formula for the slope is y2 minus y1 over x2 minus x1. Sorry, I did this a minute ago, but I wasn't recording. So if you hear me clicking, clicking through what I did. So that would be minus 1 minus 4, which is minus 3, over 1 minus minus 2 is 3. So that's minus 1 decreasing. Minus 1 minus 4 is minus 5 over 3 minus minus 1. So that's decreasing. 2 minus 5 is minus 3 over minus 1 minus 3 is minus 4. 3 over 4 is an increasing line. Minus 3 minus 4 is minus 7 over 4 minus 6 is minus 2. 7 over 2, that's an increasing. 7 minus 3 is 4 over 5 minus 2 is 3, that's increasing. 5 minus 9 is minus 4. Minus 8 minus 1 is minus 9. 4 over 9 is increasing. 4 minus 4 is 0, so that's a horizontal, and minus 4 over 0 is undefined, and that is a vertical line. Okay, now, still recording, good, we didn't crash. For the following exercise, write the equation of the line satisfying the given condition in slope-intercept form. So, there's two techniques here. I think the easiest thing just to do is to use the formula y minus y1 equals m times x minus x1. So you get y minus 3 equals minus 6 times x minus 1. So that's y minus 3 equals minus 6x plus 6. So that's y equals minus 6x plus 9. Oh, is that how they want the answer? I believe so. Let's just have a quick peek. Yeah, it is. Yep, as I thought. Okay. 68. Y minus 2 equals 3 times x minus minus 3. Y minus 2 equals 3x plus 9. That's y equals 3x plus 2. 69. Y minus 4 equals a third x minus 0. Y minus 4 equals a third x. Y equals a third x plus 4. 70. So the x-intercept, so that's 80 then. Y minus y1 equals m times x minus x1. Y equals 2/5 x minus 16/5. Okay. 71. Now we have points. So m is minus 1 minus 1 over minus 2 minus 2. That's minus 2 over minus 4, which is a half. So that's y minus y1 equals m times x minus x1. So y minus 1 equals a half x minus 1. So y equals a half x. Oh, that looks right, isn't it? It is, isn't it? Yeah. 72. M equals 2 minus 7 over 1 minus minus 3. Minus 5 over 4. So that's y minus y1 equals m times x minus x1. So that's y minus 7 equals minus 5 over 4x minus 15 over 4. So that means y equals minus 5 over 4x minus 15 over 4 plus 7, which is 28 over 4. So that means y equals minus 5 over 4x 13 over 4. Okay. Could I fit the next two in? X-intercept, that's 5, 0. And y-intercept is 0 minus 3. So for 73, the m would be minus 3 minus 0 over 0 minus 5. So that's 3/5. And that means y equals 3/5 x minus 3. There's a shortcut here. The constant at the end is always the y-intercept. So, for example, 74, I know the answer will be y equals something x plus 9. We can get the slope for this one, minus 6, 0, and this is 0, 9. So it would be, m would be 9 minus 0 over 0 minus minus 6. So that's 3 over 2. Again, hopefully in my tiredness I didn't make any silly arithmetic mistakes for all this number crunching. Let's have a look here. In the 70s. $67 minus 6x plus 9. 69, third x plus 4. 71, a half x. 73, 3/5 x minus 3. So at least the odd ones are correct. So one would hope I did not make a slip in the even ones. And yeah, okay, that's taken care of. And what's next now? For each following exercise, for each linear equation, give the slope and the y-intercept, if any, and graph the line. Okay, let's copy this again. We're good, we're still recording. Great. For the following exercises, give the slope and the y-intercept, if any, and graph the line. Okay, for 75, you can see the slope is 2, and the y-intercept, let's call it y-int for short, is minus 3. And to graph the line, it's going to cross the y-axis. It's a very crude graph. It's going to cross the y-axis at minus 3, and it's going to slope downward, upwards with slope 2. So meaning if you come out 1 unit, you have to, why did I put minus 3 up there? I'm not awake. Obviously minus 3 is down here. Come on, I really need a cup of coffee now. And there's the line. And its slope is 2, which means like if you travel 1 unit over, you'll be 2 units higher. So that would be at minus 1. So that would be a second point on it. Or if you prefer, I can put a triangle in here. So that there is 2 units long, and that's 1 unit long. So that's what it would mean. I have a slope of 2. 76. The slope is -1/7, and the y-intercept is 1. Again, quick sketch here. So that's y, and that's x, and we're crossing the y-axis at 1. And the slope is downwards, but not too steep. So you would have to travel out 7 units before you drop 1. So this point here would have to be a 7. So you'd have to travel out 7 units along the x before you drop 1 unit on the y. 77. Well, the slope is -6 and the y-intercept is 0. So it passes through the origin. And, it's going down -6. So that means when you travel out 1 unit, you've dropped 6 units here. I should say x and y don't have to be to the same scale. Like 1 unit on the x doesn't have to equal the same length as 1 unit on the y. Usually is though. But sometimes it's convenient to adjust the scales on either the x or the y. Okay. 78. So the m is -5. The y-intercept is 4. So if I sketch that out here, it means we're crossing here at 4. And the slope is -5, meaning you have to travel out 1 unit before you can go down at 5. So your line would be kind of steep downwards. That point there would be 1 - 1. You travel out 1 unit and you drop 5. Let's just have a peek at the answers, huh? $75, 2 and -3. And that's line there. So yeah, obviously they're going to use graphing software, but they say graph the line rather than sketch the line. So I probably should do a better job than what I just did there. But anyways, we can do the next one's a little neater. And then 77 -6 and 0. Yeah, because my scale is way off to fit at the bottom of the page. 1 unit on the horizontal is like kind of large, and 6 units on the vertical. So I probably shouldn't have had the scale. Like again, I repeat, the scales can be arbitrarily set horizontally and vertically, but I went a little bit over the top by making 6 units so small on the Y, because it doesn't convey how steep the line is. So I should really do better than that. But sure, look, we'll do the next ones a little bit better. Let's do these last 4 ones neatly, huh? Let's do these ones neatly. Let's even use a ruler. Let's split the page in 4. And then we'll have, let's take care of the first one. So the first one is 4y equals minus 24, which means y is minus 6. So that means the slope is 0 and the y-intercept is minus 6. So I draw my graph here. There's the y, there's the x, there's minus 6, and then there it is there. 80, 81, 82. Okay, the next one is going to be, when you rearrange it, you just get x equal to 4 over 8, which is a half. That one there is undefined slope, and the y-intercept does not exist. Because what's happening here at x is a half. What's wrong with me today? What is wrong with me today? So there's 1, for example, and there's 2, for example. So at a half here, you just have this vertical line extending. I should really put little arrows here or something to show that it's extending off to infinity. I should really do a little better. The next one, 2x plus 3y equals 6. That means 3y equals minus 2x plus 6. That means y equals minus 2 over 3x, if I divide by 3 now, plus 2, which means the m is minus 2 over 3, and the y-intercept is 2. So let's just say here, y-intercept is 2. Which means that if you travel out 3 units, you drop 2 units. So in a different color, if you travel out 3 units, you have to drop 2 units. So that would be at 3, for example. So the line would be like that. Yeah. And then 82, 6x minus 5y plus 15 equals 0. So that means you'll get 5y equal to 6x plus 15. So you get y equals 6 over 5x plus 15 over 5, which is 3. So the m is 6 over 5. And the y-intercept is 3. So the y-intercept is at 3. And then you travel out 5 units, you go up 6. So that would be like here. So the line will be kind of steep. That point up there. Travel out, what did I say? 5 units to go up 6. So that upper point there would be 5, 6, for example, and that point there would be 0, 3. No, not 0.6, sorry. You've gone up 6 units from 3, so that would be 0.9. 0.9. 9. Yeah, yeah. Okay, let's check the answers if we can. 79. 0 minus 6. It's good. And then we just have 81 then. Yeah, passing to 2 and 3. Minus 2/3 and 2. So our odds are correct again, so hopefully our evens are correct as well. Okay, yeah, that's a good point to wrap it up, because then next time we've got find the degree, find any zeros, if any, find the y-intercepts, if any, and use the leading coefficient to determine the graph's end behavior and determine algebraically whether the polynomial is even, odd, or neither. Okay, that's getting a bit more advanced now. Okay, great, great. Okay, let's wrap it up for today. Let's wrap it up there for today. Thanks for watching.